In this session, we will be learning about structures and related programs. First of all, what is a structure? Structure is a user-defined data type which has group of members or group of members of different data types. You can create your own data type where that data type contains group of other data types. For example, if we take an integer data type, a character data type, or a float data type. If you want all of them at a time in your function or in your functionality, then you can create your user defined data type and store all of those data types numbers inside a structure. So that is the definition of a structure, where you can create your own data type which has numbers of different or heterogeneous data types. You can check the general syntax of structure. Struct is a keyword where you can define your structure. Struct, structure name, and open the curly brackets. Inside the curly brackets, you will have different data types, like for example int, char, float, etc., having members of it, members of different data types. And remember, you need to enclose it with a semicolon because structure is also a data type. The only difference between structure and whatever the data types you use is structure is a user defined data type and other data types which we use are predefined data types. Okay, but both are data types, right? That's why we end the structure with semicolon. Next, structure definition and initialization. So as you know that struct, name of the structure, here the name of the structure is books, and opening the curly braces, I'm creating title, which is a character data type, or you can say it is a string because title will have set of characters, and author, which is again a string and giving a size of 50 for it. Similarly, book ID, which is an integer, I'm specifying int. And after this, we are writing book. So what is the use of this variable? Remember, this variable is different, and whatever the variable which we define as a structure name is different. The variable which we have written at the end of this structure, nothing but before the semicolon, is used to access the data members inside the structure. Nothing but if you want to access this title data type, then you can say book dot title. So what is this dot? Dot is nothing but it is an operator where you can access the data members of a structure. Okay, if you want to access author, then you can write book dot author. If you want to access book id, then you can write book dot book id. So book is nothing but it is a simple variable, okay, where you can access the data members inside the structure. Now how you can access the data members? First one is obviously the dot operator. Just now we have discussed. This dot operator is used to access with normal variables. Suppose there we have written book, right? Book is a normal variable where you can access. And what is the use of arrow operator? If you want to access with pointer variables, then you can use this arrow operator. Nothing but explicitly in the main method or at the end of the structure, if you define a variable that is a pointer variable, then how you can access the data members inside a structure? Using arrow operator. Suppose let us say if I have defined int star p, nothing but that is a pointer variable. So how can I access the data members? Suppose we have these data members title, author, and book ID. Then you can say p arrow title using arrow mark. P, this mark, nothing but p pointing to this title, which gives out the value inside this title, value or string. Okay, If you want to access author, then you can say P pointing to author, which gives the value inside the author. And if you want book ID, P pointing to book ID, which gives the value inside the book ID. So this is about accessing the data available in the structure variables. Now let us look into the main program. The basic program for structure, right? The header file, the structure definition. This is a structure student. Structure name is what? Student, which has HT number, nothing but hall ticket number, gender, and CGPA. I'm ending it with semicolon. Here I have not specified any variable to access the data members. And here comes the main method. Inside the main method, we have created a structure variable. So if you create a structure variable inside a main method, that means that you can access the structure using this structure variable. So using structure variable, what you can do? Using structure variable, we can access the structure members or structure data type members. Okay. Now I'm taking the input, enter hall ticket number, gender, and CGPA. Enter hall ticket number, CGPA, and gender. Okay. Scanning them into hall ticket number, CGPA, and gender. So how you are scanning? S1 is a structure variable. Using this structure variable and hall ticket number, you can apply dot operator so that you can access the value inside this hall ticket number. If I say S1 dot HT number, then that HT number, whatever you have written, is been assigned into this S1 dot HT number. If you write S1 dot CGPA, whatever the CGPA you will write will get returned over this S1 dot CGPA, nothing but inside this CGPA. Whatever the gender you give will get assigned into S1 dot gender, nothing but S1 is a structure variable and dot gender or dot hall ticket number or dot CGPA accessing those numbers. Okay. And here we have created a structure pointer variable. It is not a structure variable. It is also having pointer, right? So we call it as a structure pointer variable. Now what we are doing? Assigning the address of S1. Initially we have created the structure variable, right? That address is being assigned into the variable S2. So now S2 holds the address of S1. And in order to access these data members, we can access them using S2 as well, because S2 also holds the address of S1. Nothing but S2 and S1 are pointing to some same memory location. Whatever may be the memory location, both are pointing to same memory location. The only difference between them is S1 is a normal variable, whereas S2 is a pointer variable. So how you can access a pointer variable, or how a pointer variable can access the data members inside the structure? Simple, using arrow operator. So here you can see we are using arrow operator. S2 is a structure pointer variable. S2 pointing to HT number. You can check S2 pointing to HT number. That is nothing but percentile D. S2 pointing to gender, which is percentile C. And S2 pointing to CGPA, which is percent F. Okay, because they are float, char, and int values. So this above program will represent how to access using structure variable. This below one represents how to access using a pointer. Okay, structure pointer variable. Let us execute it. You can check. Let me enter 1, 9.2 and gender to be male. You can check the output is been printed. HTNO is 1, gender, and CGPA. So you need to remember that using dot operator we are scanning, or we are taking the input. but using arrow operator, we are printing the status or the input given. This is a simple example related to structure. Now let us look into structure array. What is a structure array? In the before example, we have seen that only printing one record, nothing but printing a person's or a student's hall ticket number, CGPA and gender. What if there are many students, multiple records? How you can print those multiple records? So obviously, if the term multiple comes into your mind, then you can say that array is a best suitable one to store them. So what we are doing in this program, creating the structure student, same like the before program, having all ticket number, gender and CGPA. And inside the main method, giving an iterative variable I and n to be how many records you want to store, nothing but how many number of students records you want to store. Okay, and what is this? This is very important. Without this declaration, you can't write any program related to structure array, because the programmer or whoever the person checks your program, whenever you write related to the structure array, then you must specify s array of fixed size. Okay, this is a structure array where you are creating an array, and also this s is meant for accessing the data members inside the structure as well. Okay, after that, taking the input statement, enter how many students and scan it into variable n. Now we are running a for loop till n, okay, starting from 0 till n, where for each time, for each iterative variable, nothing but for 0th, for 1th till nth iterative variable, we are scanning the hall ticket number, CGPA and gender, and keeping them at the respective indexes of the array. That means if you start with 0, then at 0th position of array, it must store hall ticket number, CGPA and gender for that particular student. If it increments now for first index, nothing but after incrementing for 1, for s of 1, it must store hall ticket number, CGPA and gender. Similarly, if you increment I to 2, then for s of 2, it must store hall ticket number, CGPA and gender. In that way, the multiple student records are being stored using this structure array. So this is the input statement, right? After that, we are printing the student records. To print the student records, obviously, you must specify a for loop till the size of your record or total number of records you have. Printing the hall ticket number, gender and CGPA. Here simply we are using dot operator. Here in this program we have not specified any pointer variable, right? Simply using a normal variable, we are accessing the data members, hall ticket number, gender and CGPA. So how you are accessing? Using for loop. Why you are using for loop? Because you have structure array. If you have array, you cannot print all values at a single time, right? So that's why we are using for loop. And for each time, like for 0th index, print the hall ticket number, gender and CGPA. For index 1, printing the hall ticket number, gender and CGPA. And similarly, up to n number of records, we are printing the hall ticket number, gender and CGPA. Let us execute this program. I want to store 4 records of students, 1 9.2 and male, 2 8.5 and female, 3 8.6 and male, 4 2.3 and male. You can check that they are being printed. Okay, hall ticket number, gender, CGPA. For respective hall ticket numbers, the genders and CGPAs. Okay, These are the student records. This is a simple program indicating your structure array. Now, let us see what is nested structure. As you know that we have nested for loop, nested if else condition. In the same way, we have nested structure. What is nested structure? A structure inside a structure. Nothing but if you are defining a structure and inside the structure, if a data type has few more division, nothing but if any data type, let us take this example, right? Inside the student, you have roll number, name, and if you give only address like char address, then what happens? That address must hold only character values. But what I want is in the place of address, it must also store plot number and area of that particular student. So what we are doing, we are again creating a structure, nothing but inside this struct student, we are creating another structure called struct address, and inside that we are giving plot number and area. Same like how we create a structure. Inside the nested structure also we are creating a structure. And remember, inside the nested structure, after creation of it, you need to specify a variable here, because that variable will be useful to access your data members inside this nested structure or inside this structure. Okay, inside this structure, whatever the structure you have, that structure data members, these both are being accessed by this variable a. And for this main structure, you can explicitly specify it in the main method, right? Like struct student s1, so that using s1 you can access those all values. Okay, this is your nested structure. Simple syntax for your nested structure. Now let us look into the program, right? Here same program I have taken all ticket number, gender, and inside address we are keeping plot number and area. This area is what? String. Why? Because you have array of 20 characters, right? Set of characters. That means a string, right? In order to access this structure data members, that is in order to access plot number and area, I am specifying a variable a. And inside the main method, now let us look into the main method. This main method has struct student s1, nothing but creating a variable to access all the data members. Not all in the sense these data members also, but this one, and address. Let us check how you can access address. So giving initialization, nothing but directly I'm specifying the hall ticket number, gender, and for address I'm not specifying only one variable because address has plot number and area. We are specifying some plot number and some area to it. After that, I am creating what? Pointer variable. Pointer variable which is pointing to s1. You can check, right? That means s2 is storing the address of s1. Clearly indicates that s1 and s2 both are pointing to your same structure or same memory location. So what you can do is using s2, you need to write arrow operator. Okay, now I want to print hall ticket number and gender. We are using arrow operator. s2 is a explicit variable which we have, the pointer variable which we have defined. s2 pointing to hall ticket number will print the hall ticket number. s2 pointing to gender will print the gender. Now how you can print 33 and the address or the area specified? Simple. Using s2, okay, pointing to what we have specified here, a, right? So this a dot plot number indicates a data type in this structure. A dot plot number indicates a data type in this structure. Hall ticket number is a data type inside this structure. Gender is a data type inside this structure. Similarly, a dot plot number. Similarly, what? A dot plot number indicates as a data type inside the structure. So what you can do? S2 is a variable, right? So generally how you access hall ticket number? S2 arrow mark hall ticket number. You can check here below, right? S2 arrow mark hall ticket number. Similarly, gender S2 arrow mark gender. So how you can access this a dot plot number? A dot plot number is also now data type. So you can write S2 arrow mark a dot plot number or plot number. So we have written the same thing here. S2 pointing to a dot plot number. Similarly, area, that is a dot area, is also a data type inside this structure student. So you can write S2 pointing to a dot area. This will give you what? The area of the student record. So from these both statements you can print hall ticket number, gender, plot number and area as well. Let us run this program. You can check hall ticket number, gender, plot number and area are being printed. This is the use of nested structures. Let us look into one more program. This is a program where we pass a structure variable to a function. So as usual, we have created a struct student having role, name, gender and marks. Okay. And this int marks array, nothing but what? Array of student marks. Okay, array of student marks. Integer array, you can say integer array of student marks. Whereas this is a character array. Is it right? Character array, where it contains set of characters. So using functions, we are doing this program inside the main method. We have created a variable which can access the structure. So directly we have given the values as well. Role is 101, name is Mary, gender is male. Okay, marks. So marks is an array which of 5, size 5. So we have given 5 elements to it. Okay, inside curly braces. Ending up this curly braces, we are calling a function. Nothing but somewhere you must define this function definition. Yeah, you can check here we have defined the function definition. So this S1 is what? This S1 is a structure variable, right? Which is a formal argument. So here you have written A. This A is what? A comes as a actual argument which is similar to structure variable S1, which is similar to structure variable S1. So you are printing name, role and gender, that is using dot operator. A dot role, A dot name, A dot gender. Okay, so marks, obviously it is an array. In order to get each student marks, then obviously you need a for loop. So for each time, each mark must be printed, taking the for loop from 0 till 5 records. Why? Because only we have specified the size of the array to be 5. Printing the marks in each subject or the 0th subject, 1th subject, etc. A dot marks of I. Same like A dot gender, we have written A dot marks of I. Okay. This is about functions. Let us execute this program. You can check whatever we have specified are being printed. Name is Mary, role and gender. Marks in 0th subject, 1th, 2th, 3rd and 4th. Okay. Let us look into another kind of program related to the structure and functions. This is a program where you have struct student, role, name, gender, and marks. Okay. And inside the main method, what we are doing is simple. The only difference between the before program and this program is here we are using a pointer variable. So how you can say we are using a pointer variable? Because we have created a pointer, and also that that pointer is pointing to the same as s1. Nothing but what is the role that s1 will do? The same role pointer will also do. The only difference comes between both of them is accessibility. For normal variable, you can do it using dot operator, whereas for pointer variable, you can do it using arrow operator. So again, calling the function, you can check the function call. Initially printing p name, so p pointing to name. Here we are using what? Arrow operator. Similarly for role, p pointing to role. Similarly for gender, p pointing to gender. And obviously marks, we have specified here marks, right? So for we are running a for loop to print each and every mark of the student. Nothing but mark of a student in each and every subject. Okay. Here also we are using an arrow mark. Okay. Remember what is this p? P is an argument, the pointer argument which we have given here. Here we use this a formal argument, and here in the function definition we are using a actual argument in order to access the numbers. And using p this operator you can access the marks. The same program, just we are using operator. You can check the name, whatever we have given, CBIT name is given, and role, gender, and marks in each subject. Let us look into self-referential structures. What is self-referential structure? Simple, a structure that has a number pointing to some data type. Okay. The name itself indicates, right? Self-referential, referring to itself. Okay. Structure has a number pointing to some other data type. Okay. You can check it right using a program. Let me tell you the next one. Structures using dynamic memory allocation. So how you can do your structures using dynamic memory allocation? It is very simple. We have created a struct student which has hall ticket number, gender, and some PER. Okay. And in the main function, we have created the variable s. Okay. And memory allocation, right? We are using malloc function. Inside malloc function, we need to have size of that data type. What is that data type? Structure data type. Okay. That's why we written size of struct student. And what is this? This is called as accessibility or assigning the values. S arrow mark hall ticket number, S pointing to hall ticket number giving some value. Similarly, S pointing to gender giving some value, S pointing to percentage, okay, giving some value. So why we are using pointing or arrow operator? Because S is a pointer variable. This is the reason we are using S as a pointer variable. Okay, that's why we are using the arrow operator, and a printf statement where we are printing hall ticket number, gender, percentage using arrow operators. So obviously whatever the memory you allocate, you need to release that memory at the end or reallocate it. That's why we are using deallocated. That's why we are using free of s. Let us compile it and run. You can check they are being printed: all ticket number, gender and percentage. Now let us look into complex struct type def. Okay, complex numbers to print sum of two complex numbers. Okay, using type def. So what is type def? Type def, okay, it is used to define data type name, new data type name, okay, to make your program more readable, where you can specify what new data type names. That is the main use of type def. You can understand it more clearly in this program. The header file type def struct complex. So instead of struct complex, we are writing type def struct complex, which is the structure name. And inside the structure, you have two data members, with obviously in complex number. What can you say? What is a complex number, right? You know it. You knew it. Complex number will have real value and imaginary value. So that's why we are taking two variables, real and imaginary. Both are set to be float. At the end, we are giving complex variable in order to map or in order to access those numbers. Now, we have used here functions. This is the function declaration. Add numbers. As I said, we are adding two complex numbers where it must take the input as first complex number, second complex number, and the result of that complex number. So what we have done is don't took it as a complex one because don't think it as a tough task. We are simply using a pointer variable in order to access these data numbers. You can use a normal variable where you can use your dot operator, okay, or you can use a pointer variable. It depends on you. And after that, this is your pointer variable. Inside the main method, I have complex c1, c2 and result. So what are this complex c1, c2 and result? They are the variables created, okay, for this, okay, complex c1, c2 result in order to access this real and imaginary. So the first step is for first number. Basically, we are taking two numbers, right? For the first number, there will be one real part, imaginary part, and for the second number, you will have one real part and imaginary part. So first, for first number, enter real part and scanning it into real. Okay, c1 is nothing but it's a simple variable in order to access them. Okay, not complex one. Okay, c1 is a simple variable in order to access this real and imaginary. And again, enter the imaginary part using c1.image, that is address of it. We are putting the value into this imaginary part. Okay, first number imaginary part. And I hope you know why we used here ampersand, that is a scanf statement. Similarly, for the second number, enter the real part, scan it into C2. C2 we have declared here, right? C2 is used for accessing the real and imaginary of second complex number. For the first complex number, we are using C1, and for the second complex number, we are using C2. So enter real part, it is being scanned into C2.real. And similarly enter imaginary part, scan into c2.imaginary. For all of them we have used %f. Okay, why? Because it is a float value. And after this function call add numbers, since our c1 c2 will have something right now, because we have scanned them, we have put some values inside that c1 and c2. So that's why I'm calling a function c1 c2 and result, ampersand result, which stores the address of result. Okay, so it goes into this part which has complex c1, complex c2, complex star result. Okay, you can write complex is nothing but whatever the variable which we have defined to access that structure. Okay, so how you will get result? result pointing to real, result pointing to real. What is this result? Result is a variable where you can access your structure, your main structure. Okay, so result pointing to real. Why pointing to real? Because result is a pointer variable, clearly we have defined there. So result pointing to real, result pointing to real, which means what? Sum of two numbers is nothing but adding those real parts and adding those imaginary parts. That is only the output. Sum of two complex numbers means adding first the real parts and then adding the imaginary parts. Storing those addition of real parts into result pointing to real and storing those imaginary parts into result pointing to image. Okay, so how we are doing? C1 dot real, which is the first number real value, C2 dot real, which is the second number's real value. Similarly, C1 dot image, which is the first number imaginary value, and this is the second number imaginary value. Okay, after that, after this function call, you are printing your result.real and result.imaginary. Whatever the addition which you have got is being printed here. So simple program. We are taking C1, C2, C1 for first number, C2 for second number, taking the real and imaginary parts of the first and second numbers, and taking a variable called as result in order to place the addition of reals of two numbers and imaginary of two numbers. How you can place result pointing to real and result pointing to imaginary? These are new variables of the addition of two numbers. The result, whatever you got on adding those two numbers, that is the variable. This result is that variable. Okay, now let us run this program. Suppose if I write 1 and imaginary part 2 for second number 3 and 4, you can check. Adding real parts 1 plus 3, it is 4. Okay, result dot real is 4. Adding imaginary parts 2 plus 4, which is 6. That is result dot image. Okay, this is your program related to type def complex program. Okay, let us learn two more concepts in structures. First one is enumeration. What is enumeration? Enumeration, obviously it is a data type. So what does it do? It consists of integral constants, nothing but whatever the names or whatever you specify inside enumeration, those values or those variables will be considered as integral constants. Whatever you specify, whether you specify strings, whether you specify characters, or if you specify numbers also, okay, those all are considered as integral constants. That's why we say that enumeration is a data type which consists of integral constants. So let us look it into an example, right? You have enum week, which has Sunday, Monday, Tuesday, Wednesday, Thursday, Friday till Saturday. Okay, inside the main method, what we have done, we have created enum week today. Today is a explicit variable, right, where you can assign something to that today. So what we are doing, assigning Wednesday to this today, printing what is the number of today, printing what is the number of today. So generally, will you get number of today? No, because that is a Wednesday, right? But using enumeration, whatever we have used here, enum and enum, you can print the integral constant or a number related to it. So how you can print that number? Remember, whatever you specify, it starts with 1. So Sunday is nothing but 1. Similarly, Monday is nothing but 2. Similarly, Tuesday is nothing but 3. Wednesday is nothing but 4. Thursday is nothing but 5. Friday is nothing but 6. Saturday is nothing but 7. Okay. So we have created a today variable and assigned this Wednesday to this today, printing what is today plus 1. Today is nothing but what? Wednesday. Wednesday is 4. So 4 plus 1. The output must be 5. That's it, right? We have used percentile. Let us check it. So you got day 4, right? Okay. So sometimes it may start with 0 as well. Okay. That's why I have taken from 1. For Tuesday it is 2. For Wednesday it is 3, and for Thursday it is 4, and for Friday it is 5, and Saturday it is 6. So today is nothing but Wednesday, which is nothing but holds 3. Today plus 1 is nothing but 3 plus 1, which is 4. Okay. So simple. What is enumeration? It consists of integral constants. Whatever you specify, the values or variables, they have some integral constant created at the back end. Okay, at the back end. This is the meaning of enumerations. And remember, an enum variable can take only one value. As I said, Sunday holds only one value, that is 0. Monday holds only one value, 1. In that way. Okay. Next, what is union? Union and structure are similar. Okay. That is the first point. The only difference between them is structure will allocate or assign required space to all of its members, whereas unions hold one member value at a time. Okay. Suppose if you have structure, inside the structure employee, you have name, salary, and worker number. Of course, this salary, this name, whatever is there, is kept as a fixed size of 32. Okay. Whereas salary, it is a float variable, right? 4, and for integer, it is a float variable, it is 4. So what happens actually in structure is this part. Okay. And this is a normal variable in order to access them. If you check union, union is represented like this. Instead of struct keyword, you are using union, name of the union. Okay. Remember, both must not be same. They both must be different. Okay. Defining a union. Okay. Same data types, char name, float salary into worker number. So what happens actually in union is 32. Obviously, it is a fixed size, because here by defining name array of 32 semicolon, this indicates that 32 size is fixed for that name. Okay. And for the salary, what happens generally in structures, 4 bytes will be allocated to the member salary in structure, whereas in union it will hold that value, that size, only at that particular time. Nothing but if there is 4, it will hold only this 4 at this particular time. Okay. After end of this 4 will get deducted and this 4 will get deducted. So what will be the size? Size is only 32. I hope why you got size is only 32, because it is a fixed size. This statement indicates that you are fixing a size to a limit, right? Whereas these both statements, you have not, these both statements are not an array. They are simply some variables, integer and float variables. So you can check here, I'm printing size of ump, nothing but a variable to access this, size of this union, and size of smp is nothing but size of this structure. You can check what will be the size. Yeah, you can check size of union is 32 bytes and size of structure is 40 bytes. So you can check how you got 40, here 32, here plus 4 plus 4. So at creation of the structure only, the size is been allocated, the enough size, whatever the required size is there for each of them, and adding up all of them, the size has been created, that is 40 bytes for structure. Whereas for union, 32 is a by default, which is a fixed size. Whereas for salary and worker number, only when we use those both of them at that particular time only, the sizes will be visible, or those sizes will be alive. After that, nothing but after that particular time, those sizes will not exist. Okay. That's why you got here 32 bytes. This is the meaning of usage of union. Structures allocate enough space to store all their members, whereas unions can only hold one member at a time. one member value at a time. One member value at a time. Here it is holding name value at a time because it is a fixed. Whereas salary hold only one its member value at a time. Okay, that is the clear definition of your union. You can clearly check difference between union and structure using size of, okay, size of command or size of syntax. It is a by default string name to show the size of the any data type. This was about your structures and union part, etc. Whatever we have discussed, right? Arrays, nested structures, and structures using functions. Okay,